So yesterday what we studied various terms including testing of hypothesis. So first of all we saw what is the need for studying this hypothesis, because from whole of this population we would take small samples out of this, right? So say this is your population, or you may call this to be the universe also, a larger set, right? And the smaller sets from here, they may contribute to be the sample. So what we do the statistics on the sample. We make decisions on the basis of the results of this sample, and then we will predict certain things about this population. So this is the funda here in the testing of hypothesis that we already studied. And we have studied about hypothesis. How do we get started with this thing? So first step was hypothesis. So whatever we wanted to test, we write that in the form of hypothesis. So that means it is a statement which is yet to be proved. And next we have seen various kind of hypothesis. The major ones, the important ones, they were the null hypothesis and the alternative hypothesis. So whatever comes to your mind, whichever thing you wanted to test, you may write that as your hypothesis, whether it is null hypothesis or alternative hypothesis. The null hypothesis would be the opposite to what you wanted to test. So basically this null hypothesis nullifies the effect for this alternative hypothesis, which was given by H0 and this was given by H1. This we have already studied. And we have seen various kind of decision errors that one could make. So we had type 1 and type 2 errors. So let's proceed further. So now once you have created the hypothesis, the next thing would be to test the statistics. And moreover, before studying this thing, if you remember, we have for sample we have the parameters which represent x bar as the mean of the sample, small s as the standard deviation for the sample, and small n to be the number of elements present in the sample, number of elements in the sample. And for the population, we have the parameters mu, which represent the mean of the population, and this sigma, which represents the standard deviation of the population, right? And then we have capital N, which represents the number of elements or objects which are present in the population. So these are the parameters. So here in case of population, we call these to be the parameter, or in case of sample, we call these to be statistic. So this is the terminology over here, right? So coming back to this testing of hypothesis, so we have different tests whenever we have depending on this n. So whenever your n is greater than equal to 30, so that means in that case we would have a large sample, and in that case we would have z test. And if you have n as less than 30, the number of elements which are less than 30, so in that case we call that to be the small sample, and for that we have t test, which is the test corresponding to means. So that means if we wanted to check about the means of two samples or the mean of sample and population, so we go for this t test. Otherwise we will go for this f test, which is used to compare the variances. So you may compare the variance of two samples, or you may compare the variance of a sample and the population. So this is also we have already covered. So now depending on which test you are using, we have different test statistic. So we have this thing known as test statistic. So this is different for different tests, but we have a general formula which says that test statistic, this is given by statistic, that means whatever is the parameter you are testing, either it is mean or variance, so that is statistics. Statistics means we are taking it from the sample, minus parameter, so that means we are taking the same same variable, either mean or standard deviation, now from the population, so that is known as parameter. So statistics minus parameter divided by standard error. So what is the standard error? This is the standard deviation of the statistics. So that means we are talking about the sample, right? So this is the general formula to calculate the test statistics. So we'll see these formulas for different tests later on. So let's proceed further with other notations. So actually what you do with this test statistics, you calculate this number and you call this to be your calculated value. So at the end of your calculation, what you do, you compare this calculated value, with that of the tabulated value. Now what is this tabulated value? For every test we have a table listed in the literature, so that means you may compare your calculated value with that tabulated value and make the decision whether you wanted to select your hypothesis, the null hypothesis, whether you wanted to accept this or you wanted to reject this. So that is the funda here. We'll get back to this thing when we solve the problem, so you'll understand this more clearly there. So for the time being, let's move on to our next term, which is level of significance. So what you do, you define the level of significance in the very starting of your problem. Now what is this level of significance? So it is a number which decides how much error you could take in whenever you are making decisions. So we say, if I say I wanted to make the decision with 95% level of significance, what does that mean? It means that if you make, or sometimes this in number, this is written as 0.95, right? So basically it means that if you make decision 100 times, so out of that 100, 95 times your decision is correct and 5 times your decision is incorrect. So in that case we say that our decision is 95% correct and 5% it could be wrong, because our results are obviously not not exact, you may say. So therefore we use this term level of significance to justify the correctness of our decisions. So generally we use 95% level of significance, so that means we may make an error of 5% in making that decision. Sometimes we take 99% as the level of significance. In that case we say we are making a very less error of say about 1%, right? In other cases we may also take this to be 90% or whatever level you would define. So that is the meaning for this level of significance. And next, based on this level of significance, for different tests you have different values for these level of significance. So based on this we define our next term, which is the critical region. Now what is this critical region? So critical region, before defining this critical region, let me tell you that all these tests, the Z test, T test, F test, and most of the tests they are approximated to normal distributions. Now what is normal distribution? It is the continuous probability distribution. So that is a part of probability distributions. So basically it is all the elements in that distribution have probability in the shape of this bell shaped data, right? So, and moreover it is symmetrical about 0. So we are saying this is a normal distribution. This is a continuous probability distribution. So all the probabilities lies below this curve. So that is normal distribution. So all of these tests, they are approximated to normal distributions. So for this critical region, what we do, we see this as the distribution, and for this particular distribution, say I wanted to test for 95% level of significance. So for this level of significance, I will go to the tabular value for this 95% significance and see for this 95% level of significance, what is the tabular value. Say the tabular value is 1.26 here, and the tabular value is minus 1.26 here. So this line would be your critical value, and your critical region would lie this here on the left side of this line, on the left side, and on the right side of this line on the right side. So this shaded portion would be your critical region. So in critical region, what we do, so this is your critical region, we accept the null hypothesis in the acceptance region. Now what is this acceptance region? The region which is not shaded. So this is your acceptance region. So if your value lie within this region, we say we accept the null hypothesis. So this is important. Make a note of it. And whenever your value lie in the critical region, which is also known as the rejection region, so we reject our null hypothesis. So we reject the null hypothesis if your calculated value, you see from here you are comparing the thing, if your calculated value, which we calculate from the test statistics, lie in the rejection region. Correct? So this is the thing. Now this line and this number, how do you select that? You select this on the basis of tabular value. So this thing would be more clear to you when we see an example for a particular statistics, right? So for this you require this level of significance, how much you want your decisions to be correct, right? So now this here in this diagram over here, you may see these two regions. Now because we have two regions, so this is known as two-tail test. Now what is two-tail test? Two-tail test is available when in the alternative hypothesis you have, suppose for this population, this is the whole population, you have two samples. For these two samples, suppose the mean of first sample is x1 or x1 bar, and for the second sample it is x2 bar, say, right? So here the alternative, we wanted to compare the means of these two samples. So what we do, we construct the null hypothesis, and we wanted here to check whether one of the two is, which one among these two is the best. So we say here that these two means they are not equal to each other. So this would be our alternative hypothesis, and corresponding to this alternative hypothesis, we would construct a null hypothesis which will state that the two means they are equal to each other. which would be opposite to this alternative hypothesis, right? So here you see, because we have this inequality, they are not equal, so in this case we would have two tails. So this is two tail test if you have this condition. But if you have this condition for one tail test, if you have your alternative hypothesis as this, x1 bar is less than x2 bar, so that means the mean of first is less than the mean of second, or you may have your alternative hypothesis as x1 bar is greater than x2 bar, so that means the mean of first sample is greater than the mean of second sample. So in both of these cases you will say that you are having one tail test. So in this particular case, your critical region would change. So what would be your critical region? Suppose this is the distribution with us, and for this tail, this is known as left tail test, and this is known as right tail test. So here in the left tail test, what we are saying, we say that a critical region lie only in the left tail. So that means we are only having this left portion of this critical region, so left shaded region. So this is only our critical region here. So we will reject only when your value lie within this particular region, and otherwise we will accept a null hypothesis. In this case, your critical region would lie to the right side of this distribution. So say this is your line corresponding to the tabulated value. So whatever is the region to the right of this thing, that would be your critical region. So in this case, the tail of this distribution lie to the right of this side of this distribution. Therefore, this is right tail test, right? So according to this is a critical region. Next thing, we may require one more thing, which is known as the degree of freedom. So what is degree of freedom? So it is the number of observations that are free to vary after certain restrictions have been placed on the data. So we may write, it is the number of observations which are free to vary. So suppose your sample has in total n elements within it, right? So its degree of freedom would be a number which is less than this number. So it would be n minus 1. So this is the degree of freedom. So basically, to calculate what is this line in the critical region, you would require two things. One is, so let me write down, to determine the tabulated value in most of the tests, you would require two things. One is the level of significance. So you would have to specify this level of significance in the very starting of the problem if it is not mentioned in the problem that is given to you. So, and second thing that is required is this degree of freedom, right? So based on these two things, you will determine what is your tabulated value, and accordingly you will have your critical region with you. So majorly let me summarize what we have discussed. So the framework for testing, so let me write that down. So firstly, what we do, we formulate the null and alternative hypothesis. That is the first step. Next, what we do, we specify the level of significance. And sometimes we also signify the degree of freedom. That depend on different kind of test. Then we select which test to be applied. So we select the test and test statistic. So when you select the test, you have you already know what is the test statistic for that, and then you compute that test statistic, right? So once you compute that, you find out the critical value from the table. So next step is to find out the critical value from table. Now for this, you would require the level of significance, degrees of freedom, and which distribution you are using. So you are requiring, you would require level of significance. First thing. Second thing, you would require degree of freedom, and you should know which test you are using. So you should know which distribution you are using. Right. So based on that, you determine the critical value from the table. Then you determine the significance of test statistics. So that means you calculate the test statistics. So here you compare the results. So this value in step 3, that is known as the calculated value, which you obtain using the formula for test statistics, and then you have the critical value which you obtain from the table. This is known as the tabulated value. So here in the 5th step, you compare the tabulated value and the computed value. So based on this comparison, you will make a decision. So based on this comparison, you will make a decision about accepting or rejecting the null hypothesis. Right, and then you will write your conclusions. Finally, you will write the conclusions based on the above procedure. Right, so this is the procedure that we have with us.